Now, are you okay with going through the rest of these sections? I think there's probably 4 or 5 more of these sections. And then there's 2 practice tests, and we've taken 1 of them. So that's the available source material we have left. You're going to have to let me know if you want to change the curriculum a little bit. In other words, if we need to speed it up, we can, and we can either skip some of these questions, although personally I think these practice exercises on these various things like ratios and proportions and stuff like that are very helpful, maybe more helpful than actually taking a test.
I think they have been too.
Okay.
So at this point, I think I'd like to continue going through these practice problems.
Okay.
I'm probably going to switch the date that I take the test because I don't feel like I am quite ready for it.
Okay.
So I probably will be booking some more time with you.
Okay. We'll continue as on then. Okay, number 1.
Okay, so this one, I guess we can pick numbers.
You could. Okay, sure.
Is that not the good way to do it?
Well, go ahead and do it that way. I like to see you use those techniques when you can, and you certainly can in this one. After we do it, I'll show you a more direct way to get it. But let's go ahead and pick numbers. How many employees?
Okay, we'll probably start off with 100.
That's fine. So,
and that would make 75 not graduates and 25 that are.
okay.
So let's see in those who are, what is the ratio of the number of college graduates to those? So it's 25 to 75. And I looked into whether we needed to reduce them since you had brought that up before, and we don't.
Oh, okay.
I mean, in this case, I realize we do, but...
Right, now I get it. Okay, good, good.
Yeah.
So that would be an acceptable answer for 1 to 3 if you had to just write an answer in.
Right.
Okay. Yeah, and that does reduce to 1 to 3, which is the same as 1 to 3. Okay, the other way you could have done this, a little bit more direct, is if 3/4 are not college graduates, 1/4 is, and we take the 1/4 relative to the 3/4, and we immediately get 1 to 3.
Oh, okay, wow, that was a lot faster.
Yeah, not that much faster. I don't mind seeing you pick numbers there at all. It didn't really take any more time, I don't think. Excuse me. Okay, what's your first inclination here?
I don't really have one.
Okay, if we have x over y equals r over t, whenever you have a fraction equals a fraction, think cross multiply.
Okay.
Okay, so if I cross multiply this, I get 2a squared equals 90. Okay, you want to take it from here?
Sure. Let's see. So divided by 2, so a squared equals 45. So D.
Got to take the square root of both sides. So A is equal to the square root of 45. And that can be simplified. Let's talk about simplifying square root, radicals. How do we simplify square root of 45? What we're looking for is factors of 45 that have a perfect square. In other words, that's...
And then times 5.
Right, which is, and now we can take that out. The whole goal of simplifying radicals is to pull out whole numbers. In other words, if I take square root of 10, is that simplified or not?
No.
Well, it's equal to the square root of 2 times the square root of 5, but this is actually more simplified than this.
Okay.
Okay? Because I'm not able to pull out a whole number. Now, make that the square root of 20, and now it's the square root of 4 times the square root of 5, and that becomes 2 root 5. So you pull out whole numbers whenever you can. And it's not simplified until you've pulled out all of the whole numbers. Now, how much you will have to do this, simplifying radicals, I'm not sure. If I said, what's this?
And I do square root of 100 times square root of 2.
Okay.
Which would be 10 to the square root of 2.
Right. The key to doing these is to know what numbers are perfect squares.
Okay.
I will write them. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. In other words, if you recognize those, then when you go to try to find factors of whatever's inside the radical, you'll be looking for these kind of numbers.
Okay.
In other words, if I do square root of 80, I know I'm looking for a 16, so that could be square root of 16 times square root of 5. And let's talk about one other thing. You don't have to find it perfectly on the first trial. Let's look at square root of 80 again. Let's suppose that I don't see that 16 is a factor, but I see that 4 is. This does not have to all be done in one step. That's where we get to, but then I can see the square root of 20 is 2 times square root of 4 times square root of 5. I can bring another 2 out, and I can still get to the same answer that I got to when I recognized that 16 was a factor of 80. So don't spend too much time looking for the greatest perfect square factor.
Okay.
Just if you can divide it by 4, it's okay to do that and then do it again and so forth. Multiple steps is just fine. If you recognize the, like 200, the perfect maximum one was 100. Back to that last problem just for a second. We got a squared equals 45. So A, I said, was the square root of 45. Technically, it's plus or minus the square root of 45. And when I say technically, I mean absolutely mathematically it's plus or minus the square root of 45. I just finally read the problem. You were correct. They asked the value of a squared. The whole time I was talking about that problem, I thought they had asked the value of A.
That's fine, because you still give me a ton of useful
Well,
information.
that's true. We got to go into how you simplify radicals, and I know that that is something you need to be able to do.
Yes, it is.
Okay. Yeah, it's funny. I usually get that question mark and the squared confused. This time I just assumed it was a question mark and no squared. So 45 was the right answer to this.
Okay.
And the only reason I brought up the other is that you'll see problems like which will require you to know that plus or minus. If you have an equation to solve, you have to take the plus or minus result. It is not correct to say that x is equal to just 2. It's equal to plus or minus 2.
Okay.
On the other hand, that is equal to 2. Because when I write the radical sign, it assumes I mean plus, in the same way that if you write anything, it assumes a plus. These two things are different, though. In this case, I'm solving an equation by having to take the square root of both sides. And in this case, I'm writing a convention where when I write radical 4, it means the positive square root of 4. Okay, number 3.
Once again, let's see, I'm looking at picking numbers, maybe 100 again, which would mean 80 rejected and 20 accepted, which would be 1/4.
Okay, which is correct.
Okay.
Okay, 1 to 4, yeah. Again, you could just use the straight percentages. In other words, 20% to 80%, percents actually cancel, and I get that same 1 to 4.
Okay.
Even without picking numbers. Okay, number 4.
Okay, well, I know choice E is going to be out.
Okay.
And I know 25 is going to be out, choice A.
Okay.
But from there, let's see, he can read 50 pages per hour. Would I set that up algebraically?
Well, this is ratios and proportions, so
Okay.
we would want to set up a ratio.
Okay.
And when you see 50 pages per hour, I can write that like this. So that has to equal some number of pages per 50 minutes. Well, I got to make sure these things are the same, so why don't I say 5/6 hours, which is 50 minutes. I could also do this. 50 minutes, and let's make this over here 60 minutes. In other words, if you do it as a ratio problem, just make sure all your units are the same. And what am I going to do to solve that? What's the first step going to be?
Multiply both sides by 50 minutes.
Correct. And then solve it. In other words, you don't want to cross-multiply here. Notice that cross-multiplying adds an extra 2 steps. It requires you to multiply both sides by 60, and then it requires you to divide both sides by 60. So just because you see a fraction equal to a fraction doesn't mean you always cross-multiply as a first step. We don't need to cross-multiply. We just need to multiply both sides by this denominator, and the problem is solved.
Okay.
So 2,500 over 60, you can do that in your calculator. I think 40, I don't know what that is. 41
Yeah,
and 2?
Yes. 41 and 2/3.
2/3, yeah. Actually, I could guess that. 6 goes into 25 4 times with only one remainder, so I know the next number is going to be 1. Okay.
Okay, what I'm looking at is, so if all the members of the team are juniors, seniors, let's see, and if the ratio of juniors to seniors on the team is 3 to 5, what percent of the team members are seniors? Would that be 5 over 8?
Yes. In other words, the total is always, you just add those up.
Okay.
So we get 8 total, 5 of whom are seniors. And again, you could pick numbers, but you can see that in a lot of these cases where we pick numbers, we can use the percentages instead of picking numbers. In other words, we could have picked 8 people on the team, 5 are seniors, 3 are juniors, 5/8 is the ratio. Finally, a geometry problem. Actually, a few of these last few sections are geometry.
Okay.
They cover circles, squares, triangles, quadrilaterals. But we have one here also.
Okay, so let's see, what is the ratio of the circumference of a circle to its radius?
Actually, number 6.
Oh, I skipped over one.
The top one there, yeah. So if we want to draw a picture, 1, 1, 2.
I'm going to...
Excuse me, that's not a good picture. Boy, apologize. X, X, 2x. Because it's the 3 angles that are in the ratio of 1 to 1 to 2. And I can't say 1, 1, and 2 because that adds up to 4, and I know these have to add up to 180. So I have to use a variable, x.
Okay. I'm not going to say it's isosceles because that would be in a ratio of 1 to 1 to square root of 2.
Well, hold on a moment.
No.
If we have 2 equal angles in a triangle, it is an isosceles triangle because the definition of isosceles is 2 equal sides. But the consequence of having 2 equal sides is you also have the opposite angles equal to one another. So the correlation is true, is that if you have a triangle with 2 equal angles, it is isosceles.
Okay.
If you have a triangle with 3 equal angles, it is equilateral. And if you have a triangle with exactly 1 right angle, it is a right triangle. So this is definitely isosceles.
Okay.
And
Help you see?
it's definitely not equilateral.
Correct, yeah.
X, X, and X. So the question is it a right triangle? And to know that, we're going to have to solve for X. So what equation can I write based on this picture to solve?
2x plus x equals 180. And so yes, it comes out to be a right triangle.
4x equals 180, x equals 45, which means the 2x angle is the 90-degree angle. So it's A and B, but not C. Now, perhaps the best way to go about this problem would have been to start off by solving the triangle in the first place. We didn't really need to solve the triangle to know that it was isosceles, but we did need to solve the triangle to know that it was a right triangle.
Okay.
And by solving the triangle first, then it's very easily recognized also as an isosceles triangle. If you didn't know that theorem that says if you have two equal angles, it's isosceles, you would know it by the time you drew your right triangle, which was a 90, 45, 45. Okay, number 7.
Well, I know the circumference is 2 pi r.
What does it mean? The ratio of the circumference to its radius means this, right?
Yes.
Okay. So it means that. In other words, here's the circumference. Here's the radius. That ratio is 2 pi.
Okay.
Okay, the ratio of the number of freshmen to sophomores to juniors to seniors is in the proportion 4 to 7 to 6 to 8. What percent of the team are sophomores?
It'd be 7 over 25.
Okay.
Which is 28%.
Okay. How'd you get 28%? Did you get the decimal 0.28?
Yes.
Okay. That's fine. What I did was I multiplied top and bottom by 4.
Oh.
That's okay. That's not a particular advantage when you have that calculator. If you didn't have that calculator, it'd be a little different story. Then I'd be spending a lot more time showing you little tricks like that. Okay, so we want to go to the next page here, number 9.
I'm just thankful that at least I'm getting some of them right today. Yesterday was pretty bad.
Typical. You know, yesterday that was a strange practice. I honestly think they gave a whole lot tougher questions.
Oh, they were
on that
hard.
percent. Yeah. And
well, I'm really bad at setting up problems.
Well, the biggest thing you need to know about percent is that you're either moving 2 decimal points to the right or 2 decimal places to the left. And that's it. If I want to convert the number 5% to a decimal, then I move the decimal points right there. So I'm going to move it 2 places, and it becomes 0.05 to eliminate the percent. If I start with 0.05 and I want to convert that to percent, I'm going to multiply it by 100 instead of divide it by 100. And that's equal to 5%. So converting between decimal and percent is a piece of cake. That's not ever a mistake you should make. However, that test we looked at yesterday, or those exercises, those were way beyond that. They took that simple principle and wrapped it around a whole bunch of difficult word problems and stuff like that. So, all right, let's look at 9.
But I need to figure out how to do those, so.
Well, true. Those are definitely going to be some of your more difficult problems if they're, like that. But that's the biggest thing about percent to understand, whether you multiply by 100 or divide by 100.
Okay.
Number 9, Spanish to French is 7-2. So what's the ratio I can set up? We got Spanish to French equals 7-2 equals what to what?
140 for the French, and then X on top.
So now you have to solve that equation.
Let's see, if I did this correctly, it comes up to 490.
Correct. Okay. These problems here. I personally am not real fond of the colon if we're talking about ratios. Ratios are fractions. And if I'm going to do a ratio problem, I'm going to start off by converting all my colons to fractions. Now, colons come in handy if you have, 3 different entities, like the freshmen to sophomores to juniors to seniors. But in problems like this, where there's just 2 variables, I would start right off by saying A over B equals 3 over 5 and proceed accordingly.
Okay. Okay, so for 10, I would want to put, well, I want to make the A's equal.
Okay.
The way I do these ones is I made A equal, so I multiplied A by 5 and B by 5.
Okay.
On the
So now you have A over B equals 15 over 25.
Correct.
Okay.
And then I multiplied C by 3, which equals 21. So B to C would be 25 to 21.
Beautiful. I love that technique. I was going to, if you are good at that technique, that's exactly the quickest way to solve this problem.
Oh, good. Because
the hard way would be to solve for A in terms of B, and then substitute that, and then just reduce that remaining fraction to a b over c. But the way you did it was much better, quicker.
So I'm going to say cross multiply.
Okay.
So we have 2x equals 36 divided by 2.
Okay, we have x squared equals 36. When you multiply x times x, it's x squared.
Okay, so x squared equals 36. So x equals 6.
Right. Once again, x equal plus or minus 6, but if they're only going to put plus answers on there, there's no question.
Okay.
The only reason I keep stressing that is because you're going to run into a problem that says, what's the product of the solutions to this? And if I had x squared equals 36, and I said, what's the product of the solutions? 36 would not be the answer, because the solutions are plus and minus 6, and so it's plus 6 times minus 6, so minus 36 would be the product of the solutions.
Okay.
Okay? Just in case we run into a problem like that, where we need to be able to use the plus and the minus. Okay, so here I have B to A, if you can't read that, is 7 to 2. And they want to know what B minus A is.
This one I'm not sure where to start.
See if you can figure out what the angles B and A are. What do we know about B and A?
Will they be 180 degrees?
Okay, so they have to total that.
Right.
So can you figure out which, do a little trial and error. Pick an angle for B and an angle for A such that they total 180 and they're in a 7 to 2 ratio. Notice the 7 to 2 ratio totals 9, which is a factor of 180. But I actually like this technique of a little bit of trial and error, so let's kind of look at that a little bit.
Okay.
Pick what you think would be a ballpark number for B, such that B to A is going to be in a 7 to 2 ratio. It's not going to be 100 degrees, because then A would be 80. It's not going to be 160, because B...
Or we could just say 110.
Okay. Is 110 to, well, the other one would have to be 70. Is that a 7 to 2 ratio?
No.
Okay, let's try some other numbers. Got to increase the B.
So 160 to 20.
Is that a 7 to 2?
No, it's 1 to 8.
Okay, it's 8 to 1, right?
Oh, yeah, 8 to 1.
Okay, so let's try another one. Now, I know this seems like a ridiculous task, but it's not so ridiculous. There are situations where you would want to use this technique.
Okay. And I'm looking at the answers and going by that. So 100?
That's probably a mistake here.
Is it? Okay.
Yeah, and I'll tell you why. Is because
we're doing B minus A?
I don't consider this a back-solving problem.
Okay.
If they said, what is B, then it would be a back-solving problem. I could just pick one of these and see if it's in a 7:2 ratio with its complement or its supplementary angle. But they're asking for a difference, which is altogether different. They're not asking for a single entity. So I do not consider this a back-solving problem, but it could be a trial and error problem. You've tried 110 and you've tried 160. Let's try another one.
Yeah, 90? No, because 90
has to be between 110 and 160, because when you were at 110, you were way below this ratio, and when you were at 160, you were way above this ratio.
So 150.
Let's try 140, only because it's a nice multiple of 7, whereas 150 is not. Notice that this is 20 times bigger than this, and this is 20 times bigger than that. And I should have known that 20 because these total to 9. We know that the two angles total to 180. 180 divided by 9 is 20. So for every degree, I need 20 of these and 20 of those. So it comes to 140 to 40. Now, that can also be done algebraically. I'm not necessarily suggesting that you use trial and error on these. Just want you to be aware of that technique. The official way to do this is, let's first of all put it in a fraction. Not the official way, but the way I like to do it. And then the other thing I can say is A plus B equals 180. So B is equal to 7A over 2 by solving that. And substituting that, I get A plus 7A over 2 equals 180. And I can solve that easy enough to come up with an A of 40. So one way to look at this is you have two equations and two unknowns. There's the first equation, there's the second equation. And I can solve whenever you have two equations and whenever you have two unknowns and two independent equations, you can always solve by substitution or elimination. So B minus A is 100. Because it had 140 minus 40. And that's what makes it difficult to try to back solve it. Because we're solving...
I'm not looking for one variable.
Difference, exactly. Exactly. As I said, had they just asked for B, back solving would have been wonderful. Or even just A. All right. 13.
So this one looks like it would be I divided by M equals F divided by H.
I inches divided by M minutes would equal how many feet, question mark, feet per H hours.
Okay, so I would want to pick a number? Maybe
Yes.
60 minutes?
Well, we could work with this. First of all, this is ratios and proportions, and so it might be worthwhile figuring it out this method. But the method I far prefer is picking numbers, and I see it instantly because I look at a problem that has 1, 2, 3 variables in it, and I'm looking at answers that all have 3 variables in it. That, to me, is a clue that you can definitely solve this with picking numbers.
Okay.
All we have to do is pick an I, an M, and an H, figure it out in our head, and then figure out which of these 5 answers equals that number we came up with. However, to convert this problem, in other words, we've set it up as a proper proportion. We're trying to solve for x. This is in inches. Yeah, I inches. So we need to convert the feet to inches, and we need to convert the hours to minutes. Well, I would have to multiply this by 12 inches per 1 feet. That gets rid of the feet. Now we have inches in the numerator. And the hours, I'm going to have to convert that 1 hour per 60 minutes. Notice that I set it up so that the hours will cancel. I ran out of room here. This is supposed to be to the right of the 12 inches per minute. So now we have everything solved, and we can actually figure it out. We have I over m. I have to divide by 12, and I have to multiply by 60. So this should be the number of inches that I move in h hours. I totally screwed this up algebraically. I did the conversions in the wrong way. Since we're trying to find feet per hours, let's not waste any more time on that and do it the way we should have done it. I was trying to do the book method, which will work, but you got to get all your units properly. Let's pick numbers. Give me some numbers for I, M, and H.
I was going to do pretty much 1 inch, and so 12 inches per, I was pretty much picking the same numbers that you put in here, 12 inches, 1 inch.
Well, let's start with I. So you're going to say I is 1.
And then minutes 60, or 1. And then feet, I was going to change to 12 inches. And 1 hour I was going to change to 60 minutes.
Okay. You need to pick an H. So let's pick an H of 1.
1, okay.
Okay, because 1 hour. So now, internally, without trying to memorize formulas, if a snail can go 1 inch in 60 minutes, how many feet can it move in 1 hour?
1. Oh, wait. Okay, if a snail can move, let me see, 1 inch in 60 minutes, then that is 1 hour, so.
Right, but it's only going 1 inch in 1 hour. So how many
right.
how many feet does it go in 1 hour?
112.
So that's our answer, based on the 3 numbers you picked.
Okay.
Now let's go through each of these and figure out which one is equal to 1 over 12. Well, A is 5 times H, which we picked of 1, an I we picked of 1, and an M we picked of 60. Bingo. That's equal to 112.
Okay.
And that's the answer. Now, as always, with picking numbers, you have to be a little bit careful. If you're pressed for time, I would go on as soon as you get A. If you have extra time, it would be worth checking the others to see if any of the others also come out to be 112. In which case, we'd need to go back here and pick a few different numbers and then narrow down between those two.
Okay.
Okay? In this case, the answer is A, and I don't think it's worth our remaining 10 minutes to go over and do the arithmetic of the other 4 answers, because that's all it is. The key here is the methodology. You pick an I, you pick an M, you pick an H, and then based just internally, you were able to figure out how many feet it could go in H hours. You didn't need to know the distance equals rate times time, which is a good formula to memorize. That is something you're going to need to know. The distance equals rate times time, but that was something we can do internally in our head. We know that if it goes 1 inch in 60 minutes, it goes 1 inch in an hour, and if it goes 1 inch in an hour, it's going 1/12 of a foot in 1 hour. Okay. I have a way of wording some of these problems that I've never seen worded before like this. We ran into one the other day also, yesterday.
I'm actually glad to hear you say that, because some of these I don't get it. It's like, what?
Exactly, and this is one. So let's write out what we know. If she can grade t-tests in 1 over x hours, how can I write that?
T equals 1 over x?
How about t divided by 1 over x?
Well, I am really bad at setting these up.
Well,
how do I know that it's
use the units? If you use the units, then all of these ratios, if I drive 40 miles in 1 hour, I can write that as 40 miles per 1 hour.
Okay.
Okay? So that's the secret, is to take the verbal information and then just set it up as a ratio. Okay? So that's the rate that we're driving.
Okay.
Or the rate that we're grading. Well, what does that equal to if you do the algebra?
It's equal to tx.
So at this rate, how many tests can she grade in x hours? If I'm driving at 40 miles per hour, how many miles can I go in 3 hours?
120.
So I multiply.
Yes.
Gets rid of the hours and the hours. Well, this is tests per hour. So if I want to figure out how much I can there is an interesting thing to note here. When we did the algebra and we flipped the bottom and multiplied, you do not flip the bottom's units. In other words, I flip the 1 over x so that I end up with tx is my rate, but it's tx tests per hour. In other words, this still stays the same and this still stays the same. Even though I've flipped the 1 over x, I don't have 1 over hr that I have flipped. In other words, my answer does not come out tests hours, it comes out tests per hour.
Okay.
So that's my grading rate. So if I want to know how many I could grade in y hours, I would multiply this by y, txy. If I want to know how many I can grade in x hours, I got to multiply this by x. So it's tx squared is the answer.
Could you explain that last part again just real quick?
Yeah. Tx is my rate of grading. It's like
Okay.
my rate of driving. It's very similar to being able to go 40 miles an hour, only I can do 40 tests per hour.
Okay.
Only in this case, I can do T times X tests per hour.
Okay.
Well, if I can do that rate, and I can do it for X hours, then I'm going to multiply Tx times X. If I said, how many could she grade in 10 hours, your answer would be 10Tx. If I said, how many could she grade in Y hours, your answer would be Tx times Y. So the only
Okay.
thing they've done is to try to confuse the issue by using the same variable, which means you still multiply X times the grading rate, which is T times X. So you end up with T times X, or
Okay.
Tx squared. Yeah, let's go on. I don't think it's too worthwhile to spend a huge amount of time on those. We'll come to them. It seems like in every practice exercise they have a problem kind of like that, where they use variables and they are intentionally trying to confuse you.
They succeed.
Well, me too. That was a hard problem for me also when I saw it. And the thing is that you have to remember the methodology. Just remember the methodology. In other words, if I can grade T tests in 1 over X hours, then I have to write T divided by 1 over X. That's my grading rate. Okay. How are you going to do 15?
Not too sure.
Back solve. Notice that we can't pick numbers, but we can kind of back solve. Now, this might not be as smooth of back solving as the other back solving, because this could be an issue of we're not necessarily going to know if we have to increase or decrease, maybe. I don't know. Can we, let's start with 14.
Okay.
Can we figure out a breakdown of 14 that results in boys to girls being 3 to 4? Total those up. What do they add?
7.
Okay. Since 7 is a factor of 14, that's a real good thing. That means we can do it. 14 is twice 7. So if I double each of these, I get 6 to 8. Well, 6 to 8 is the right proportion, and it adds to 14. So B is a possible answer. That doesn't mean it's the correct answer yet. But notice that we could not even break 12 down such that it's in a 3 to 4 ratio.
Correct.
There's no way to break 12 down to give a 3 to 4 ratio. And the reason I know that is because 3 and 4 adds to 7, and 12 is not divisible by 7. 21 is. 21, notice, is 3 times that total. So all I have to do is multiply both of them by 3. So 9 is to 12 would also be a possible answer. 28 is also divisible by 7, so I could make it work. So now let's start with the first one we got, 6 to 8. Is that correct? same number of boys and girls joined. So can we subtract the same number from each of these two numbers and get back to the 3 to 5 ratio?
Well, yes, if we took away 3 from the boys, we'd have 3, and 3 from the girls, we'd have 5.
So B works instantly, and we're done. Notice that this answer, which was D, if I subtracted, there's no constant number. I'd have to subtract 6 to get 3 boys. And if I subtract 6 from that, I would have 6 girls. So it doesn't give me that 3 to 5 ratio.
Got it. Okay.
This one, I subtract 3 to get 3. And if I subtract the same number, I get 5.
Got it.
Okay? So the reason this is a back solving and that other one was not, where they asked for B minus A, it's kind of a similar situation. They really have asked for a ratio, and there's no way we can pick one number and immediately go through it. But we can pick a number and figure out, is there any way I can break this up into that 3 to 4 ratio?
Okay.
So in a way, 15 is similar to 12. I could have done the same thing to 12. Can I break up 180 degrees such that their difference is 100? Well, yeah, if I had 140 and 40, I don't know. It's not really worth talking about, but for some reason this is easier for me to do, is to figure out which of these answers could be set in this ratio.
Yeah, that made sense.
And it has to do with that being a multiple of their total. That total is 7, so we're looking for numbers that are multiples of 7.
Okay.
All right? All right, we'll end it on 15 and pick up next time. By the way, if you want to schedule an appointment and you don't see an open spot, like next week, if Tuesday and Friday were the only days you could do it, by all means let me know. I can put you in at 10 a.m. on Tuesday, and I could move my golf back on Friday. So
okay.
Don't be completely constrained by what you see available.
Okay.
Okay? Those are general block-offs. I don't have golf games set for each of those days.
Well, have fun golfing today. Hopefully that smoke isn't going to be bothersome.
Thank you, and I'm sure I will. Angela, you have a good day too, and I'll talk to you next time.
Okay, thanks. Bye-bye.
Bye-bye.